we have to find out the incenter of the triangle formed by the sides y equals to 15, 3x minus 4y equals to 0, and 5x plus 12y equals to 0. Now, we can find out the incenter in two ways. One, we can find out the equation of angular bisectors, and the point of intersection is coordinates of the incenter. The other way, what we can do, we can find out the vertices coordinates, then we can apply the standard formula by finding out the distance of the sides. Then we can use ax1 plus bx2 plus cx3 by a plus b plus c for x coordinate, and for y coordinate ay1 plus by2 plus cy3 by a plus b plus c to find out the coordinates of incenter. Now we will do both the methods. We'll start with finding out the point of intersection of angular bisectors. Now we know that angular bisectors are equidistant from the sides. So let's write down the equation of the angular bisectors, and remember that whenever we try to find out angular bisectors, we'll have two angular bisectors. One will be acute angle, one will be obtuse angle. What we need to select, that we have to decide which is more appropriate for us, and the other one we have to discard. So let's go ahead and write down the equations for angular bisector for y equals to 15 and 5x plus 12y equals to 0. So I'll write down y minus 15 divided by root 1 equals to plus or minus 5x plus 12y divided by root of 5 square plus 12 square. That will give us y minus 15 equals to plus or minus 5x plus 12y divided by 13. Let's do the cross multiplication. We'll have 13 into y minus 15 equals to plus or minus 5x plus 12y. Now we will get two angular bisectors. Let's write down the first one. 13y minus 195. By taking only plus, I will have 5x plus 12y. That will give us 5x minus y equals to minus 195. Now let us see whether this is the angular bisector what we need. For that, we know that the angular bisector will be coming in this direction. So the y-intercept of the line should be between 0 and 15. Now look at this line. What is the y-intercept? If you substitute x equals to 0, we have y equals to 195. That means now that line is not the line actually what we need. So this is not what we need. So we'll just discard this. I hope you understood the logic. Let's go for the other one with minus. So that will be 13y minus 195 like earlier equals to minus 5x minus 12y. Simplify that, we will have 5x plus 25y equals to 195, or we can simplify that as x plus 5y equals to 39. Now look at what is the y-intercept of this. 5y equals to 39, y equals to 7.8, and that is between 0 to 15. That means the line is going to come and hit at 7.8, which is actually the angular bisector what we need. So we got one angular bisector. Let's write down its equation. The equation what we got is x plus 5y equals to 39. So I'll write down here. One is x plus 5y equals to 39, and that one is hitting when x equals to 0, y equals to 7.8. So it's like approximately coming like that. That is the angular bisector we have. That is x plus 5y equals to 39. Now let us take y equals to 15 and 3x minus 4y equals to 0. Find out the other angular bisector. We know again that the y-intercept should be between 0 to 15. So let us see how the angular bisector equation will be. Then we will solve them by elimination method. We will get the coordinates. Let's go to the next system. When we take y minus 15 equals to 0 and 3x minus 4y equals to 0 and want to find out the angular bisectors, equation will be y minus 15 divided by square root of 1 equal to plus or minus 3x minus 4y divided by square root of 3 square plus 4 square, which will give us y minus 15 equals to plus or minus 3x minus 4y divided by 5, or can we say that 5 into y minus 15 equals to plus or minus 3x minus 4y. We'll take one time plus and one time minus. First let's do the first one. By taking plus, we will have 5y minus 75 equals to 3x minus 4y, or can we say that 3x minus 9y equals to minus 75, or we can divide by 3 and write down x minus 3y equals to minus 25. Now let's look at what is the y-intercept of this line. If I put x equals to 0, I have 3y equals to 25, y is 8.33. So that is exactly coming like the same point like earlier. So this is the correct angular bisector equation what we are looking for. So we don't need to substitute for the minus 1. We'll go ahead and write down this equation. X minus 3y equals to minus 25. And that line is hitting exactly at 8.33. So that line is coming like this. And this is where we have our coordinates of in-center. So let's go ahead and solve these two equations to find out the coordinates of in-center. We have x plus 5y equals to 39, and we have x minus 3y equals to minus 25. Let us do subtraction so that we can eliminate x. We have 8y equals to 64, or we got y equals to 8. Now we can get the value of x by substituting in x plus 5y equals to 39, which will give us x equals to 39 minus 5y, which is equals to 39 minus 40, which is equals to minus 1. So the coordinates of in-center you can also see from the figure, that is minus 1 comma 8. Now that's the coordinates of the in-center. So this is one method. Let's do the second method, in which we'll find out the coordinates of the vertices, then we'll apply the standard formula. We'll try to finish it fast. Let's name the labels, the coordinates. So what the vertices? Let us say this is A we have, and this is B, and we have C. Let's find out what are the coordinates of A, B, C. For that, A will be obtained when I take y equals to 15 and 5x plus 12y equals to 0. B can be obtained when I take y equals to 15 and 3x minus 4y equals to 0. And C can be obtained when I take 3x minus 4y equals to 0 and 5x plus 12y equals to 0. So first we'll find out the coordinates of A, then find out the coordinates of B, coordinates of C. Then we'll find out what is this small a, small b, small c. Then we'll apply in the formula ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 divided by a plus b plus c. Let us take y equals to 15 and 5x plus 12y equals to 0. Y equals to 15, 5x is plus minus 180, x equals to minus 36. So we have coordinates of a as minus 36, comma 15. From there we got x1 and y1. Let's go to b. Y equals to 15. Then 3x minus 60 is 0. X is 20. So 20 comma 15. From here I got our x2, y2. Let's go to C. We have 3x equals to 4y. So 9x is, oh, this will be 0 comma 0 because on the right side we have zeros. So it should be only 0. Okay. So we have x1, y1, x2, y2. Let's write down. This is our x1, y1. This is x2, y2. And this is x3, y3. Now what is small a? Small a is nothing but distance between B and C. You can B and C. Let's find out the distance between B and C. Square root of 20 square plus 15 square, that is square root of 625, 25. Small b is distance between A and C, that is square root of 36 square plus 15 square. 1296 plus 225, 1521, square root is 39. And for the small c, that is small c, for the small c, we have distance between A and B, that is 20 plus 36 whole square plus 15 minus 15 whole square, that is 56. So we have everything ready. We have to just to do substitution. That's it. So let's go ahead and finish this. A into x1. First we'll write down a plus b plus c. That is 25. 64 plus 56. 120 here. 120 here. We'll finish in one step. A into x1. That is 25 into minus 36. Shall I write down the value directly? 25 into minus 36 is minus 900. Plus b into x2, 39 into 20, that is 780. We know x3 is 0, so we can leave it there. Let's go to a into y1, 25 into 15, 375, plus b into y2, 39 into 15, that is 585. Let us simplify that. We will have minus 120 divided by 120, comma 960 divided by 120, which is nothing but minus 1 comma 8. So we found out the coordinates of incenter by both the method. One by finding out the equation of angular bisectors and finding out the point of intersection of them. Another one, we found out the coordinates of the vertices. Then we found out the distance between the vertices, are basically the sides of the triangle. Then we applied the standard formula. So these are the two ways how. Now only the point is like we have to be very careful is like when we have two angular bisectors, we have to see which one is our candidate, which one is not. For that, we can one option what you can do is you can look at the slopes and see if two lines are, suppose let us say not this case, but suppose let us say two lines are having positive slope, then the angular bisector also will have positive slope only. So that is one way you can check it. Otherwise, you can check for the y-intercept because here we can see that this line y-intercept is 0, this line y-intercept is 15. my angular bisector y-intercept should be between 0 to 15. So it is going outside. That means that is not the one what I am looking for. So this way we can find out the coordinates of in center.